Assalamu alaikum dear viewers, welcome back to my YouTube channel. I hope you are doing well. Today we will start unit number 3, which is vectors. So in this lecture we will discuss about the vectors, that what is vector and what are their properties, and then we will solve the question number 1 of exercise 3.1. So let's start. First of all, I will tell you about the vectors. The first definition given in this chapter is the scalar. A physical quantity which can be completely specified by its magnitude only is called a scalar quantity. For example, mass, time, distance, volume, etc. So basically, we come to know that the scalar is a physical quantity, and it requires only magnitude for its complete measurement. That is known as a scalar quantity. But if a physical quantity requires both magnitude and direction as well for their complete measurement, then that physical quantity will be known as vector quantity. And examples of vector quantity are weight, displacement, velocity, acceleration, force, etc. So the scalar and vectors are both physical quantities. Scalar required only magnitude for their complete description, but vector require magnitude and direction for their complete description. So let's start some of properties of the vector. So first definition here is the magnitude of a vector. So magnitude is the distance from the origin to the head of the vector. For example, if we draw a vector A and the initial point is the origin and the final point is point A, so the distance from origin to that point means the length of this vector is known as the magnitude of the vector. And magnitude is denoted by uh, this. So this description is used for the magnitude of a vector or this. So you have to remember both of these notations for magnitude of the vector. The next definition is about the equal vectors. So two vectors are said to be equal if they have same magnitude and same direction. So both magnitude and direction will be the same for the equal vectors. So here the vector A and B are the equal vectors since they have the same magnitude, same length, and same direction as well. The next is negative of a vector. As the name suggests, the negative vector is a vector having the same magnitude but opposite in direction of the given vector is known as the negative of that specific vector. For example, if we consider this vector A, then minus A is the negative of this vector since both have same magnitude, but minus A is opposite in direction to A vector. So this vector is the negative of this vector A. Next is zero or null vector. As the name suggests, the zero or null vector is the vector which has zero magnitude, zero length. It means we cannot draw that vector physically. So here is a specific definition. If the initial and terminal points of a vector coincide means meet at a point, then the vector has zero length. So this vector is known as the zero vector or null vector. This vector has two names and it is denoted by this notation O. Next is unit vector. Unit vector is a vector in any direction which has a magnitude 1 is known as the unit vector and it is denoted by this symbol. So if a hat is appeared on any letter, so you have to know that that represent the unit vector. So unit vector has magnitude 1 and zero vector has magnitude 0. So if we have to find the unit vector in the direction of a given vector, then we will use this formula. You have to remember this formula. For example, if we are given a vector A like this and we have to find a unit vector in the direction of this, for example, here is a unit vector. So if we have to find this unit vector, then we will use the formula this formula states that we have to divide the vector A with the magnitude of that vector A, and the resultant is the vector representation of that unit vector. Next is parallel vectors. So two vectors are said to be parallel if one vector is denoted as the scalar multiple of another vector. For example, if a vector is this, if a vector is 2y minus 2j, and if we take 2 common from this, So I minus j will be the remaining part here, and we represent this remaining part by b vector. So a is equal to 2b. Then we say that a and b are parallel vectors, and we denote it like this. This is the notation for parallel vectors. So two vectors are parallel if one can be written as the scalar multiple of another vector. This scalar multiple can be a positive number, a negative number, or 0 as well. Next is the position vector. As the name suggests, it represents the position of a point from the origin. For example, if we have a point P and we have to find the position of that point with respect to origin, so we will draw a vector from origin to that point P, and that is known as position vector. Next topic is about the addition of vectors. So two vectors can be added by three methods. First one is head to tail rule or triangle law of addition. Next one is parallelogram law of addition, and the third one is polygon law of addition of vectors. So there are three methods for the addition of vector, and you have to know about all these methods. First one is triangle law of addition or head to tail rule. So in this method, if we have to add these two vectors a and b, first of all we draw vector a and then vector b in the manner such that the tail of vector b coincides with the head of vector a, and here is the head of vector b. So then we draw the resultant of these two vectors, means the sum of these two vectors, which is also a vector which starts from the tail of vector A to the head of vector B. So the tail of resultant coincides with the tail of first vector, and the head of vector coincides with the head of last vector. So in this order we draw the vectors in the order that tail of vector coincides with the head of vector. So that's why this is known as head to tail rule or triangle law of addition. Since these three vectors make a triangle, so this is also known as triangle law of addition. In parallelogram law of addition, we add the vector in the same manner, and we draw vector a here and vector b here, and then complete the remaining sides of the parallelogram. We all know that the opposite sides of parallelogram are parallel and equal. So if here is vector b, then here this line must represent a vector b, and these both represent the vector a. So if we find the resultant of these two vectors, then we draw the resultant here, and a and b, this half part of the parallelogram represents the triangle such as this triangle. So it means we again use the head to tail rule here, and these vectors form a parallelogram. That's why this is known as a parallelogram law of addition. And in the third method, we will add 4 to 5 vectors or infinite many vectors like this. So first of all we draw vector a, then draw vector b in the orders as we discussed in the head to tail rule. That is, the tail of vector b coincides with the head of vector a, and then draw vector c, vector d, and vector e as well. Then we have to find the sum of these vectors. So first of all we will draw the resultant like this and this line, and then we add the two vectors, first two vectors a and b. The sum of a and b is represented by this line named as ib, and then we add this ib and this c, which is represented by the resultant ic. Then we add ic and d, and the resultant is id, and finally we add id and this e vector, and the resultant is ie. So ie is the resultant of or the sum of all these vectors a, b, c, d, and e. So ie is the final answer of these all vectors. Next is the subtraction of two vectors. In the subtraction, we add the vectors as in the head to tail rule, but for this minus sign, we simply change the direction of the second vector. So if we have to find the difference of these two vectors a and b, first of all we will draw vector a then vector b, and here we alternate the direction of vector b. Vector b's direction is here, and we draw minus b like this, and then the resultant will be a minus b, which is the required answer of our difference question. Next is scalar multiplication. Scalar multiplication, as the name suggests, in this method we will multiply a scalar number to a given vector. For example, if a vector a is here and we multiply it by 1 by 2, 1 by 2 means the half of vector, so the magnitude of this vector is remains the half of this vector. 2a means the double in magnitude of vector, and minus 2a means the double in magnitude but opposite in direction. So here we multiply minus 2, 2 and 1 by 2, which all are scalar numbers. So that's why it is known as scalar multiplication. Now we will solve the question number 1 of exercise 3.1. Question number 1 is, in the following find the required vector in its component form given that p, q, r and s. So here 4 points are given and we have to find the vector pq in component form. Means here the point p is written in the form of bracket, but we have to write the answer in the form of components, means I, j and k. I represent the x component, j represents the y component, and k represents the z component. So if we have to find the pq, which means q minus p, you have to remember that to find the pq vector we always subtract the initial point from final point. So first we write the final point, that is q. So write here the coordinates of q, minus 4 minus 6, and then coordinates of p, that is 3 minus 1. Then subtract the corresponding coordinates, that is minus 4 minus 3 and minus 6 minus minus plus 1, that is minus 7 and minus 5. So in the form of coordinates, in the form of components, it will be written as minus 7i minus 5j. Then comma will be removed from here. Next is 3pq minus rs. So pq means q minus p and rs means s minus r. So by putting the values, q means minus 4 minus 6, p means 3 minus 1 and minus s means 2 5 and minus r means 1 4. So 3 as it is, minus 4 minus 3 is minus 7 and minus 6 plus 1 will be minus 5. I write directly in this step. I hope you are understanding this concept. 2 minus 1 1 and 5 minus 4 also 1. Then 3 will be multiplied inside. So 3 minus 7s are minus 21 and minus 15. Then 1 1 as it is. Then we will subtract the corresponding coordinates, that is minus 21 minus 1, which is minus 22, and minus 15 minus 1, which is minus 16. So this is the required answer. In components form we write it as minus 22i minus 16j. So this is the final answer for second part. In third part we have to subtract r and p, r minus p and s minus p. Then we will put the values here. R is 1 4, p is 3 minus 1 plus 3, s is 2 5 and p is 3 minus 1. Then we will subtract 1 minus 3 is minus 2. 4 plus 1 is 5 plus 3 as it is. 2 minus 3 minus 1, and 5 minus minus plus 1. 5 plus 1 is 6. 2 will be multiplied inside. Minus 4, 10, minus 3, and 18. Minus 4 minus 3 minus 7, and 10 plus 18 is 28. So in component form it will be written as minus 7i plus 28j. In next part, 3 square is equal to 9. PS means S minus P. 4 square is equal to 16, and SP means P minus S, and QP means P minus Q. Then we will put the values. After that we will simplify each bracket. So 2 minus 3 minus 1. 5 minus minus plus 1 is 6. Minus 16 as it is. 3 minus 2 1, and minus 1 minus 5 minus 6. And next is 3 minus minus plus 4, which is 7, and minus 1 plus 6, which is 5. So 9 will be multiplied inside, that is minus 9, and 9 6 are 54. Minus 16, and since minus is written here, so the same sign will be written here. 1 is plus 1, so plus 16, and minus 6 means minus 96. And next is 7 5 as it is. Then we will subtract these two brackets first, and then the answer will be added to 7 5. So next step will be minus 25 plus 7, which is minus 18, and 150 plus 5, which is 155. And in component form we will write it as minus 18i plus 155j. This is the final answer for fourth part. And in the last part we will put values first. PQ means Q minus P, 5 by 2 as it is. PR means R minus P, and S minus Q. So by putting values we get this step, and then after simplification we come to next step, which is minus 4 minus 3 minus 7, and minus 6 plus 1 minus 5 plus 5 by 2 as it is, and 1 minus 3 minus 2, and 4 plus 1 5, then minus 3 by 2 as it is, 2 plus 4 6, and 5 plus 6 11. Then we multiply 1 by 2 inside, so minus 7 by 2, minus 5 by 2, minus 5, 2 and 2 will be cancelled out, and again 5 5s are 25 by 2, minus 2 3s are 6, so 3 3s are 9, and next 33 by 2. So minus 7 by 2, minus 5, minus 9. This will be the first component, and the second component will be minus 5 by 2 plus 25 by 2 minus 33 by 2. So if we write this in component form, we will get minus 35 by 2i minus 13 by 2j. So this is the final answer. So here we will end our lecture. In the next lecture we will solve question number 2, inshallah. Until then, you remember me in your prayers, and take care of yourself. If you didn't subscribe my channel yet, go and subscribe my channel and hit the bell icon for the notification of next videos. Allah Hafiz.